This is question number 6, problem 11-20 of session 1, chapter 11, homework 1. A stock has a beta of 1.15 and an expected return of 13%. A risk-free asset currently earns 2.8%. A, what is the expected return on a portfolio that is equally invested in the two assets? So expected return on a portfolio is the weighted average of the returns of the individual assets within that portfolio. If we go to the session 1 lessons and pull out my lecture slides. Yeah, actually I already did that, so you can see that so expected return of a portfolio is right here. Yeah, the return on a portfolio is the weighted average of the returns on the stocks, on the individual assets within that portfolio. So RP is the expected return of the portfolio, and RB is one asset. RS is the expected return of another asset. And WB is the weight on the first asset, and WS is the weight on the second asset. The weight is simply the proportion of the wealth invested in that asset. So WB is the proportion of the wealth invested in the first asset, and WS is the proportion of wealth invested in the second asset. So that's how we get the expected return of a portfolio. And once we understand that, we can just we can just use different tools to solve this problem. Here I choose to use Excel because I found this to be very convenient. So here is also equally invested in the two assets. So that means 50% of the wealth is invested in a stock and 50% of the wealth is invested in the risk-free asset. So we know the stock expected return of the stock is 13%, and the return of the risk-free asset is 2.8%. Hence, so if I put this input here, our stock is 13%, right? Yes, and RF is 2.8%. Okay, so and RP, that's the portfolio, is the weight, right? The weight. So the weight. So W stock is 50%, right? Because they are equally invested. And WF, risk-free asset, is also one minus that. So hence it's 1 minus that equals 1 minus this. So it's also 50%. Hence, portfolio expected return is the return on the first asset multiplied by the weight on the first asset, the stock, plus the return on the second asset, risk-free asset, times the weight on the second asset. And so that's the final answer. So now go back to the setup. Note the rounding requirement. Do not round intermediate calculations. And that's another reason I prefer to use Excel, because by using Excel, it automatically meets this requirement. Enter your answer as a percent rounded to 2 decimal places. So I need to change this format. Right-click on the cell and choose Format Cells and change this to be percentage in the category percentage, and keep 2 decimal places. So this is already 2 decimal places, and click. Okay, so 7.90%. And that's my first answer, 7.90%. So let's continue. Part B, if a portfolio of the two assets has a beta of 0.92, what are the portfolio weights? So now we have to use another fact of the portfolio to solve out this equation, which is the beta of the portfolio is also a weighted average of the betas of the individual assets within that portfolio. And the weight is also the proportion of the wealth invested in that asset, in a specific asset. So I think the equation is somewhere also on the next slides, or at least mentioned. Yeah, portfolio beta. So the beta of the portfolio is the weighted average of the betas of individual securities in that portfolio. So it's the same, similar to the expected return. And now we just need to solve out the different inputs, the weight. Now the portfolio beta is 0.92. So let me go back here. Beta P is 0.92. And the beta for the first asset within that portfolio is the beta of the stock, which is 1.15. So beta stock is 1.15. And beta of risk-free asset, free, so that's simply 0, right? The risk-free asset has a beta of 0. That's a known fact. And now we know that the portfolio beta 0.92 is a weighted average of the betas of these two betas. And the question here is, what is the weight that stock? What's the weight? And hence, what's the weight of the risk-free asset? So if we know the weight on the stock, the weight on the risk-free asset is simply 1 minus that. Here is a question mark, hence this is the error. But now I want to use a function within Excel to solve out this equation. So let's assume that the weight on the stock is just half and half. Okay. So once the weight on the stock is 50%, hence the weight on the risk-free asset is 1 minus that is also 50%. Now, obviously, this is an arbitrary chosen number, so it may not, most likely it's not the correct answer. But what I want to do is to proceed to calculate beta P. I call this 1. Okay, beta P1. The portfolio beta, if the weight turns out to be this. And we know that given given the fact that the portfolio beta is the weighted average of the individual betas within that portfolio, so now we know the weight and we know the individual betas. So the portfolio beta can be calculated as the beta of the first asset, which is the beta of the stock, times the weight on the stock, which is 50% here, and plus the beta of the second asset, which is the beta of the risk-free asset, that's 0, plus the weight on the risk-free asset, that's the here. So you can see, as we said, if the weight are like this, the portfolio beta will be this number, and this number is not what we want because we know that portfolio beta is 0.92, right? So these two numbers do not match, but with a function in Excel, I can find out the weight on the stock, which will make this calculated beta of the portfolio to be exactly equal to this set value of 0.92. So let me use that. I go to data and what if analysis, go seek. So I set cell. So yes, exactly, this is my goal. So I want to set this cell to be the value of the known portfolio beta, which is 0.92. By changing cell, by changing what cell? This cell of this, the portfolio of the weight on the stock, and click OK. So you see that Excel automatically calculated out, figured out, only when the weight on the stock is 80%, hence the weight on the risk-free asset is 20%, that the portfolio beta will be 0.92, which is exactly equal to this number. So, okay, and then sometimes this may be a rounded number, so we have to make sure that we're combining with the rounding requirement. So the part B is the round your answers to 2 decimal places. So I need to change the format here to 2 decimal places. I think, yeah, the exact answer is also 80%. Yeah, because the reason I want to change the format here is because sometimes this may be 0.82, 84. So if you only keep 1 decimal place, this will also show up as 0.88. But that may not necessarily meet the tolerance level requirement of Connect. So have to make sure that we change the decimal places of the answers to match with the requirement. The weight of the stock is 80%, 0.80. Hence, the weight on the risk-free asset is 0.20. So that's part B. And part C, if a portfolio of the 2 assets has an expected return of 9%, what is its beta? So here, we are provided with the expected return of the risk-free asset, and we know the portfolio return, the return of the portfolio is 9%. What is the beta? And here we want to use the CAPM, the model CAPM, capital asset pricing model, because this model can link the inputs together, right? So return of an asset equals risk-free asset, the return of the risk-free asset, and that's given, and beta, we need to solve out this beta, right? We know this R times RM minus IF. So the only unknown here is RM. So how do we, well, how, if we can figure out RM, then we can plug in all the inputs to figure out the expected return of the portfolio. So how do we know the RM? We can actually figure out RM based on the setup here, because we provided with the stock, expected return of the stock. We know the beta, we know the risk-free asset. So we actually know a return of the stock here, and we know the risk-free asset return. We know the beta. So the only unknown here is the market return. So that's what we can figure out by solving this equation. So to make it more clearer, let me write down what I have shown you. So basically, what we are doing here is so this is RS stock RF equals RF beta S times RM minus RF. So here, this RF is given to be 2.8%. And this beta stock is 1.15. And this RS is 13%. So, and this is the same, 2.8%. So you see, the only unknown here is RM. So we can figure out this RM, right? We can solve out, if we use algebra, we can just move this to the other side first, and then change the sides of the equation. So this will become beta S times Rm minus RFF equals Rs minus Rf. So if you change this Rf to the other side, you have to change the sign too. So then if we divide both sides by this Rf beta S, and then the left hand side will become Rm minus Rf equals Rs minus Rf over beta. So now I can solve out this Rm. Rm equals moved minus Rf to the other side. Hence, it becomes plus. So this is actually beta S. I have to add that beta S, not to be confused with the beta P portfolio plus Rf. So then you can simply plug in a number. Rs is the 13%. RF is 0.028, right? 2.8%. And beta S is 1.15. And this is 0.028. Okay, so that's the, yeah, that's, so then you can put this into your calculator or Excel to figure out the answer, and then plug in the numbers. But what you need to note is the rounding requirement. Do not round intermediate calculations. Hence, I do not suggest you to just only keep 2 decimal places for RM. That's why I also prefer to use Excel in this case to solve out the this equation. So how do we solve out? We can also use goal-seek. So let me assume a number. So suppose RM is 10%. Obviously, this may not be the correct answer. But given that RM is 10%, my stock return, which I call R stock 1, will be based on the CAPM model. Risk-free asset, RF is here, right? Plus beta, the beta of the stock. What is the beta of the stock? Beta of the stock is right here, 1.15 times this RM. Here is 10% minus RF. Okay, so this stock, expected return of the stock if RM turns out to be 10% will be 11.08%. And this is not equal to the actual return, expected return, which is 13%. And that's to be expected, right? Because I only arbitrarily assumed 10% to be the expected return on the market. But now I want to use the goal-seek to solve out the precise value of RM, which makes this R stock 1 to be exactly equal to this 13% by changing cell this. So you see here I don't have to round. Yeah, Excel automatically keeps a lot of decimal places. Yeah, so that's why I like Excel. It automatically meets the rounding requirement. So only when RM equals this 0.116696, where the stock expected return on the stock to be exactly equal to 13%. So now with this RM and go back to C. If a portfolio of the two assets has an expected return of 9%, so now the return of the portfolio is 9%. That's given. And we know the market return, and we know the risk-free rate. We know the risk-free rate. So the question asking what is the beta? Again, if we go back to this equation here, CAPM equation, we know, basically we know this. We know the portfolio return, we know the risk-free asset, we know the market return, we know the risk-free asset, so we can solve out this beta. Again, if we use algebra, we can just do a similar rearrangement of the equation. We can solve out that beta very straightforwardly. But here, I also want to use Excel to solve out that equation. Beta, how do I use that? So I can also use the goal-seek. So beta P, suppose, yeah, this is 1 point, suppose this is 2. Yeah, any arbitrary number. Obviously, this may not be the correct portfolio beta, but I want to use this to figure out the R expected return on the portfolio, given that portfolio beta. I can use CAPM now. So this is a risk-free asset plus beta times return on the market, which we just calculated, minus risk-free rate. RF. So obviously this is not correct because I just randomly choose a number 2. But again, I can use GoSeek to find out what beta will make this RP1 to be exactly equal to 0.09. So I set the cell to be 0.09 by changing beta and OK. So see, I figure out only when beta portfolio is 0.69902 that the expected return of the portfolio will be exactly equal to 0.09. Go back to the rounding requirement. Round your answer to 3. Again, this is 3 decimal places. So I have to change this to be 3 decimal places. It's 0.699. 0.699. So the last part, if a portfolio of the 2 assets has a beta of 2.3, what are the portfolio weights? So here we also using the same fact as we did for part B. The portfolio beta is the weighted average of the betas of the assets within that portfolio. Here we're given the portfolio beta. I think this part is exactly the same as this part, so I don't know why they have to. So the trick is the same, right? Portfolio weights the same here. Just changing the beta of the portfolio. So, and that's another part which I like about Excel, because now we can just change this value. Change this value here to be other than 0.92. I change this to be 2.3 equals 2.3. So now I need to make the weight here. I need to make this GoSeek. Yes, this is a B8. B8, the portfolio. Yes, the stock beta times weight, the B weight. Again, this is the arbitrary chosen. And this number, this answer, the weight on the stock is the answer for part B, but obviously this weight will change for this part. So now this becomes an arbitrary number. And plus B9. So B9 is this beta of the risk-free asset times the weight on the risk-free asset. So now I need to set this value not to be 0.92, but to be 2.3 by changing cell W stock. Okay, so you see that this becomes, relatively speaking, this is a weird number, right? The stock actually is 2. What does this 2 mean? 2 means is 200%. And risk-free asset is will have to be negative, is a negative number. So that's why if you read the rounding requirement, negative amount should be indicated by a minus sign. So minus sign. So what does this negative number here mean? This means that we are actually not investing. We are not investing in this risk-free asset. We are actually borrowing money. We are borrowing money we are investing, but we are borrowing money to invest in the stock. So 200% of our wealth is we are investing all of our wealth, which is actually not the whole, but we are, in addition to the whole wealth, we are also borrowing money to invest in stock. Hence, we are not getting the. So what happened here is that we are investing all of our wealth in the stock here. But in addition to that, we are also borrowing money, borrowing the same wealth as we have to invest in the stock. But we are borrowing money at an interest rate, right? We need to pay the interest once we borrow money at the interest rate of this risk-free rate. Hence, we are actually not investing in the risk-free asset. We just becomes a borrower of the risk-free asset. And that's why the risk-free weight becomes a negative amount, as we just calculated. This will be -1. So now this is 2 weight of stock, and this is -1. I think that's the purpose of this part D. In addition to what we did for part B, because for part D, it turns out the weight here is a negative number. So I want to further explain what happened by using the capital market line. So what happened here is so this is the market portfolio. Oh. This point here is the so what happened here is that this is the market portfolio, then this is a risk-free asset. We know that a balanced portfolio, so the job of a investor is to choose a point on this capital market line, which is the combination of the risk-free asset and this market portfolio, right? So that's based on the separation principle. So if the point turns out the investor is investing somewhere here in between the risk-free asset and the market portfolio, then the weight will be a number which is between 0 and 1. But what happened in this part D is that investors actually are investing somewhere here. So yeah, they are putting more money than their total wealth in this risky asset. And how can they get the money? They borrow. They borrow at this risk-free asset, risk-free interest rate. And so they are investing somewhere here. And that's why the weight on this market portfolio turns out to be more than 1. And if the weight on the market portfolio is more than 1, the weight on the risk-free asset has to be a negative number, right? Because they are borrow. The borrow means that they are paying money, hence the weight will be a negative number. So that's what happened here. So now let's check whether we got the correct answer. Yes.